All right, in this video we're going to talk about density for Chapter 1 content for Chem 161. And so density is a property. Density is an intensive property. Meaning it doesn't change given the amount of material that we study. And density is a physical property. As well. Okay, so the equation used to determine density takes into account the correlation for density between mass and volume. So it's simply the mass of the material divided by the volume of that material. So you have a certain mass and a certain volume, and the ratio of the two would be your density as a whole. You can see here that we would end up with units from this calculation that combine two of our base units that we've seen before. So we've seen grams can be had as a unit for mass, and we can also end up with volume as, for example, milliliters for the volume there. Now it's common to also see volume reported not only in liters or a version with a prefix like milli in front of it, but also shown in the threefold dimensions on distance. So that is recognizing that 1 milliliter is equal to 1 cubic centimeter. We can sometimes see these units as grams per centimeter cubed. And recognizing this is important because it can help you with certain calculations for structures if you know the dimensions X, Y, and Z for that material. Okay, so going back to a famous material that we're used to thinking about, water. So we've seen before liquid water. It can be shown with the following information, H2O, and we put a subscript L to indicate the liquid state for its physical state. And we know that liquid water has a density of 1.00 grams per milliliter. Okay, so again, if we had 1 milliliter of water, we know that the mass there would be 1.00. You'll likely see in one of your labs that density is actually a property that varies with temperature. So you do need to understand temperature for certain density values to hold. So this density value shown here is only good for temperatures around room temperature. Okay, so let's take a look at an example here where we're using the density equation here to help us. We'll also give you a bit of a trick. Some people like to use these calculation pyramids that can come in handy. I pretty much prefer the top version if you want, but these calculation pyramids tell you that the mass part here divided by the volume is equal to the density value. The density is actually most commonly given symbol rho. And so to better report this, we would do symbol rho there. So here you can see that rho is equal to mass over volume. If you want to solve for mass, mass is equal to rho times the volume. And if you want to solve for volume, it's equal to mass divided by density. Okay, so there's a little bit of a visual, if that helps you with equations that are this simple. Okay, so here's our question. Our question is to calculate the density of fool's gold that has a mass of 25.392 grams and a volume of 5.28 milliliters. Okay, so we'll start with our density equation. Rho is equal to mass over volume. And so in this question, we're simply to install the mass number 25.392 grams divided by the volume information 5.28 milliliters. Okay, so notice here that we were provided the information that is giving us units already in those that are most common for the density. So most density values are reported in grams per milliliter or grams per cubic centimeter. So that will be how we approach this problem, is to make sure that we report out an answer that is in grams per milliliter for our answer. Okay, so if you punch away on the calculator, you'll see here that this turns out to be 4.8090909 grams per milliliter as our answer. We don't stop at this point because we're now armed with knowledge on significant figures. We can take a quick look at the level of sig figs in each of the inputs here. So this was a division equation after all. So it looks like this first number has 5 sig figs in it, and this next number has 3 sig figs in it. And so if we're using a division and that's it, then we know we have to report out our answer to the fewest number of sig figs to give our final answer. So we need to report out to not the 4, the 8, but end it somewhere around here. And so we'll round up per our knowledge of rounding and report this out as 4.81 grams per milliliter is our final answer there. Okay, so notice that we've combined 2 base units here, the gram and the milliliter, to give us this ultimate answer here in density, and we have combined values here, and these do not simplify any further to some special symbol for density. We report density as grams per milliliter. Okay. Let's take a look at another example here where we might try to transform units into another. So here we're given the density of ethanol is 0.789 grams per milliliter. And we are told to answer the question, what is the density in different combined units in pounds per gallon? Okay. And we'll provide some given information. Given So we know that 1 kilogram is equal to 2.2046 pounds. We also know that 1 liter is equal to 1.0567 quarts. And we also know that 1 gallon is equal to 4 quarts. Okay, so pause the video here and see if you can calculate the density of ethanol in different derived units using the given information here. Okay, so we're already given the density here, and what we want to do is set up some calculations that make use of these identities that were provided in the given information. So we'll start with what we know and what we're after. So we're after some answer here that has units that are pounds per gallon. Okay. And we're going to start with the information we have, which is 0.789 grams per milliliter is what we were given. We are now going to multiply this by a series of conversion factors that are derived from the given information to help us transform this. We will show that by unit canceling that we can start to walk this information to new information by looking at what's given. So starting with grams to milliliter, we want to transform grams ultimately into pounds. So perhaps we can start by transforming grams into kilograms. So let's cancel the gram and get into kilograms using a conversion factor. So that's what we have in the parentheses here. Okay, so let's do 1 kilogram is equal to 1,000 grams. This, as you can see, by simply doing this, would transform the number from grams to now kilograms per milliliter. So by dividing by 1,000, we end up with a number that's 1,000-fold smaller, of course, and our density is now kilograms per milliliter. Okay, so that's a step in the right direction, but we're not yet there. Another conversion factor that's needed is now coming from the information that I was given. We know that there are 2.2046 pounds per kilogram. And this now sets up the canceling of those new units that we just positioned, the kilograms. We would now, having multiplied by this, be able to report our answer out as pounds per milliliter. A step in the right direction, but we're still not done. Let's now start to do some work on the denominator, the milliliters piece here. Well, we know that 1 liter is equal to 1.0567 quarts. So if we could get the milliliters part into liters first, then we'd be able to use that blue information above. So let's do that. Let's cancel the milliliters. And I know that 1 liter is equal to 1,000 milliliters. And so if we stopped there, our unit canceling would tell us that the milliliters end up canceled, and we now inherit liters as the denominator if we stop the calculation there. Let's keep going, and now use that blue information to help us get out of the denominator liters this time, and instead get into quarts, which would then allow us to use the final identity, which is the gallon information. Okay, so let's cancel the liters. So it looks like 1 liter is equal to 1.0567 quarts. And then we can use the final bit of information here, knowing that 4 quarts is equal to 1 liter. And that would give us our answer. So I'll just try to make some room to show the next part of the calculation here. Delete out our little trick here. And punching away there, you should find that you get to an answer that is roughly had by doing 0.789 times 1 divided by 1,000. That's the first one. Times 2.2046 divided by 1 times 1,000 divided by 1 times 1 divided by 1.0567 times 4 divided by 1 would give us our answer. So on the calculator, the answer would be 6.58438,308 pounds per gallon. And we now need to think about significant figures. Okay, so it's known from information in your textbook. I'll put some where it's known that we have some exact information present. Let's list the infinite sig figs conversion factors here. So this one here is infinite sig figs, so there's no significant figures to account for there. Now in the pounds to kilograms value, we have this as being an actual 5 sig fig value. Okay, so it's not an exact value in this case. This has some precision that's been established by an experiment. So no infinite sig figs there. We need to respect the 5 in the numerator there. This one here, I'll box it in again, has infinite sig figs. As does the final one, the 4 quarts to a liter. And I'm sorry, the 4 quarts to a gallon. That was a gallon there. I'm sorry. So that's infinite sig figs there. And the last one there, liters to quarts, is also inexact. So there is 5 sig figs to account for there. Okay, so this value here has 5 sig figs. Okay, so that's how we worked the multiplication and division, and we started with a number here that had 3 sig figs. So fortunately for us, we need to report out to the number of sig figs that is reflected with the number that we started with in the 0.789. Our conversion factors have 5 sig figs at the fewest, and every other one is at infinite. So we're going to be okay to report this final answer out to just 3 sig figs, and we'll stop at 6.58 pounds per gallon. That will be our final answer there. Okay, so again, note the little mistake I had there in setting this up, but thankfully we caught it, and we've got our answer.